Hi everyone! In this video, we're going to show a sample problem for non-repeated quadratic factor under the topic Integration by Partial Fractions. This is the sample problem. Evaluate the integral of this rational function 3x squared plus 2 all over x minus 2 times the quantity x squared plus 1 dx. Let us copy this problem down here. We take note that the degree of numerator is less than degree of denominator. Therefore, this is a proper fraction. Let us copy this fraction on the right side. Analyzing our denominator, we can see that the first factor is a non-repeated linear factor, while the second is a non-repeated quadratic factor. Resolving this now into partial fractions, we will have a over the first factor x minus 2 plus bx plus c over the second factor x squared plus 1. Now we can show that our integral is an integrals of partial fractions. So we have the integral of a over x minus 2 dx plus the integral of bx plus c all over x squared plus 1 dx. Now let us solve for a, b, and c. Let us multiply this equation by the LCD. Note that the LCD is the denominator of the left-hand side. By doing so, the resulting equation now becomes 3x squared plus 2 equals a times the quantity x squared plus 1 plus bx plus c times the quantity x minus 2. This is now our working equation. Let's start by solving for a. We let x equals 2 so that the b and c will be eliminated. By doing so, we have now 3 times 2 squared plus 2 equals a times the quantity 2 squared plus 1 plus the bx plus c becomes b times 2 plus c, and the x minus 2 becomes 2 minus 2. This 2 minus 2 will give us 0, and this 0 when multiplied by 2b plus c will cancel this 2b plus c. Now let us simplify the equation further. The left-hand side becomes 14 equals the right-hand side is 5a. Then the value of a is 14 over 5. Now let us solve for c. We substitute the value of a in this equation and we let x to be equal to 0. So we have now 3 times 0 squared plus 2 on the left equals 14 over 5, that is the value of a, times the quantity 0 squared plus 1 plus b times 0 plus c times the quantity 0 minus 2. We can show that we can cancel all the zeros in here. By simplifying further, the left-hand side becomes 2, and this is equal to 14 over 5 minus 2c. When we simplify this equation, we will get the value of c, and that is 2 over 5. So we have now two values, which are a and c. Let us solve for b. What we're going to do here is to substitute the values of a and c in our working equation, and we let x equals 1. So we have now 3 times 1 square plus 2 equals the value of a, 14 over 5, times 1 square plus 1 plus the quantity b times 1 plus 2 over 5. This is the value of c, times the quantity 1 minus 2. Simplifying further, the left side becomes 5 equals, this group here will become 28 over 5 minus b minus 2 over 5. Simplifying this equation, we can get the value of b, and that is 1 over 5. Now the values of a, b, and c are complete. We are now ready to do substitution to the values of a, b, and c in the integrals. This is now the resulting integrals. Simplifying further, this second integral here, we're going to split the sum of fractions of the numerator. So we will have 1/5 of x is here, plus the 2/5 will be here. And we will get that same denominator. Going further, we're going to put the constants outside the integral sign. So it will be like this. Now let us solve for the integrals. Note that the first two integrals can be solved by substitution. It means we can let u to be the x minus 2, and we let w the x squared plus 1. Note also, the third integral is a special formula that will give us the tangent inverse of x. So the next step will be 14 over 5, the integral of 1 over u du, plus the second integral will be 1 over 5 times 1/2 times the integral of 1 over w dw, plus the constant 2 over 5 times the tangent inverse of x. The first two integrals here will give us natural log. So the next step, we will get 14 over 5 times the natural log of the absolute value of u, plus 1 over 10 times the natural log of absolute value of w, plus the 2 over 5 times tangent inverse of x. If we replace the corresponding values of u and w, we will get 14 over 5 ln of absolute value of x minus 2, plus 1 over 10 ln of absolute value of x squared plus 1, plus 2 over 5 tangent inverse of x. Of course, we will not forget the plus c, the constant of integration. This is now the final answer. I hope you learned something from this video. See you again next time.